Thank you very much, Roberto. And I must say, as an art historian, I'm fascinated by these architectures that reminds contemporary museums as well as medieval cathedrals with their domes, which is extremely interesting. And now we pass from the dark matter to life sciences. It's my pleasure to introduce Professor Elisa Araldi, the youngest member of this panel, from Castel San Giovanni near Piacenza, who studied at my same university, another motive of proud for me, the Scuola Normale Superiore and the University of Pisa, where she got her first degree in cellular and molecular biology. Subsequently, she did a PhD in pathobiology and translational medicine at New York University. She then carried out research activities in several international most important places, such as the Harvard Medical School, the New York University, Yale University, and the Polytechnic, the ETH in Zurich. She currently is Junior Professorin for Computational Systems Medicine at the University Medical Center in Mainz. Recently selected as a winner of the Early Career Fellowship Program promoted by the Human Technopole under the patronage of the Ministero dell'Università della Ricerca, she has chosen the University of Parma to conduct her interdisciplinary studies on cholesterol biosynthesis with a combined approach of genomics, physiology, and data science. Elisa will talk now about systems medicine and big data as engines of growth. Thank you very much, Elisa, and you have the floor.
Thank you, Chiara. Very generous. Thank you for the invitation. It's a big pride to be here amongst excellent scientists, which have much greater experience than me. But today I hope I will convey my excitement for the science that I do. So systems medicine, what are we talking about? About myself, you don't need to know because you heard it before. But so systems medicine is the new frontier of medicine. So you go to the doctor prescribes you a medicine, a drug, because, well, there are standard algorithms. That's what you take when you have diabetes, metformin, when you have high cholesterol, statins. But is this sufficient? I mean, we're in 2023, we can use so much technology to understand more and actually improve human health. So that the idea is to transition to systems medicine where we understand so much about the patient, so much about the system that we can prescribe a personalized drug, a personalized treatment so that we avoid side effect. We cure exactly to the spot in record time and super efficiency. Now, probably a dream, yes, but we're working towards this dream. So what does system medicine need? It needs big data. To understand things, we need to see things, we need a lot of information from different points of view. So obviously from experiments, this is a bit what the life sciences have been doing so far, small experiments, bigger experiments, but also anything that belongs to the human. So how does a person live? What's their lifestyle? What's their environment? Are they smoking? Are they overweight? Do they exercise? Have they been to the hospital? Were they in an accident? Do they have family history of diseases or other things? And then on top of that, we need also their samples. We need pieces of them to further analyze them and to see things that you would not understand otherwise. And so for doing that, we have biobanks that collect genetic data, that collect what's floating in their blood, which proteins, which metabolites, what is happening in their microbiome, and so on. Obviously, these biobanks are not an easy task. They're big enterprises, big efforts, and they're coupled with everything else regarding a patient. So we follow these individuals and we see what happens to them over time. We study anything that it's belonging to them, and then what do we do? And so that's what system medicine, where system medicine comes in. Sorry, I'm messing up. Sorry, oops. So it comes with statistics, with computational modeling and machine learning. We take all this data, a lot of data, we crunch it, we do some magic, and then we have systems medicine. Now, what do we get? So we understand the disease better. We can diagnose earlier and prevent the disease. We can create new therapeutic targets. We can stratify patients. Individuals are not all the same because of genetics, environment. We can really distinguish patients and then know how to treat them better. And all in all, personalized treatment. Now, this is where I see growth. If you can devise new therapeutic interventions, then of course you make more effective therapies. Pharmaceutical companies are of course interested in patenting the latest drug that makes a lot of money, obviously. You have a healthier population. This is priceless, but not so priceless because then you have lower healthcare costs. So this is a bit what is the goal with systems medicine, but now going a bit in more details, which data do we use? So here you have a scheme of the data that is available to us when we take a piece of the patient. So we know their genetic composition, their DNA, but then there are other things that we can progressively know that are less written in stone, like the DNA, but more molded by the environment, such as epigenomic, transcriptomic, proteomics, the famous omics. They're very fancy right now. But we're basically all these molecular data, but not only, also phenomics, which is how a patient looked, what has been through, clinical data, and so on. So in this schematic example, so when we have all this layer of information from a lot of individuals, we can actually understand diseases better. We can draw the connections, integrate all these multiple fields, and then in the example of type 2 diabetes, we can understand in a patient whether this type 2 diabetes is coming from defects in insulin secretion or defects in insulin sensitivity. And of course, then we treat the patient accordingly to which type of deficits or impairments they have. But we need big data. And the different health organizations and research institutions in the world have come up, each of them individually, but as a whole, with the great effort to create biobanks and population cohorts. The beauty of that is that the data is available to other researchers, so that's also science, right? So the knowledge is freely available with reasonable requests. But there's a lot of them, and you can see the number of people some of them include. Germany has this beautiful biobank alliance with 4 million samples. The UK biobank, 500,000 samples, million samples in this other US biobank. I want to give you a couple of examples of this country, although this country is doing excellent. Germany is doing an excellent job with biobanks and population cohorts. And then I will want to show you what Italy has been doing. So a pride of my adoptive city, Mainz, is the Gutenberg Health Study. So there are about 18,000 participants. They're very well characterized. The study started in 2007, and the individuals are followed up every 5 years. And we have 11,000 data points per individual, and up to 5 million samples from those individuals. So you understand the amount of data that we have, and the type of analysis, the type of data that is acquired comprises a lot of different aspects of these individuals, and a lot of research endeavors are in all these disciplines. It was started mostly for cardiology. Obviously, cardiology brings a lot of people, unfortunately, to the hospital. But then, thanks to the amount of data that was collected, then different other disciplines could use the data to do research and understand more. Germany has a lot of population cohorts. This is just one. But I just want to give you a glimpse of the Italian ones. One is the CRIS Biobank. So it comprises 13,000 inhabitants from the Südtirol. And it has a lot of not only information on the patient itself, but also samples, also pieces of the patient, and with the hope of generating even personalized cells from these individuals, so induced pluripotent stem cells, so that you take a piece of skin of the individual, and then you can generate neurons or cardiomyocytes. So this is definitely very ambitious. The other quite big Italian cohort is the Molisani, and it's a cohort that, as the name says, it's a combination of Molise, a region in Italy, and sani, which is healthy in Italian. And it's a project born, again, to study cardiovascular diseases with about 24,000 individuals over 35 years. A lot of research, a lot of insights, quite an obvious one, but nevertheless was quite interesting to see in this longitudinal cohort is that ultra-processed food intake leads to earlier mortality. Not that very surprising. But nevertheless, Italy has a few population cohorts. Those are just two. And you see here the logo of the Human Technopole. Why I'll show you that? Because the Human Technopole is a new research institution in Italy for the life sciences. It had opened 5 research areas that you can see here. And the excitement is that the Human Technopole was able to recruit recognized scientific leaders from abroad. We stole the director of the Max Planck Institute of Molecular and Cellular Biology, Marina Zerial, who's going to direct the Human Technopole soon. And in the research area of genomics, we stole from the UK a great female scientist, Nicole Soranzo, and Pietro Carnici from Japan. Their job now is actually to take those cohorts that I've just shown you and vamp them up. So not only analyze what they've always analyzed, but go really deeper and do post-genomic analysis on them, because the Human Technopole has so many facilities that it's now possible to go back to these biobanks and get even more out of them. Incidentally, the Human Technopole is also the institution that has given me this fellowship to return to Italy. The very last slide is the biobank that I'm using, or that I've historically been using before coming to Mainz, is the UK Biobank. A lot of data coming from the UK Biobank, 500,000 volunteers. And my research questions, a couple of my research questions is, can we understand a bit more about longevity? Are there the medicines, are there drugs that will increase our longevity? And what I will study next is how do cholesterol precursors regulate life? We can talk about it at the reception. I'm not going to bother you with that. I'm concluding, thanking the founders so far. If you are in the life sciences and you know people that want to come back to Italy, I'm hiring, so just so you know. And with this, I'm concluding and leaving the stage to Chiara.